Here are the first 5 terms of a quadratic sequence. Find an expression in terms of n for the nth term of this quadratic sequence. So the first thing that we need to do is we need to figure out the second order difference. So I'm just rewriting it so I've got plenty of room. So to get from 4 to 11 we're adding 7, 11 to 20 is adding 9, 20 to 31 is adding 11, and 31 to 44 is adding 13. Which means that my second order difference is adding 2. And whatever the second order difference is, we always halve it, and that will give our value of n squared. So if it's 4, it would be 2n squared. If it's 6, it would be 3n squared. Because it's 2, we're just looking at n squared. So if I just write out my terms, I'm going to find the first, second, third and fourth. And I know that n squared therefore is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. And I know that this sequence is somehow, so our sequence is somehow related to n squared. So it's 4, 11, 20, 31. I could do the fifth term if I wanted to. I'm now just going to check, is it the same amount going from 1 to 4? So 1 to 4 we're adding 3. To get from 4 to 11 we're adding 7. To get from 9 to 20 we're adding 11. And to get from 16 to 31 we're adding 15. So I'm just going to, it's not adding the same thing, it's not the same number. We're going from the n squared row to the sequence row. So I'm just going to rewrite that green sequence out. So 3, 7, 11, 15. And you can see that this is actually a linear sequence. We're going up in 4s. So it's the 4 times table, so it's 4n. But the 4 times table starts at 4. We've started 1 below that, so that's minus 1. So to get from the n squared line to the sequence line, what we're doing is we're effectively adding 4n minus 1. So therefore my whole sequence is n squared, what colour should I use? N squared plus 4n minus 1. That will give you this line here. So we've got n squared, n squared plus 4n minus 1. There's my final answer.